Ever wonder what happens after you click Buy Now on Amazon? Behind that instant purchase lies a global machine of AI, robotics, and human precision. From warehouse shelf to your doorstep, this video breaks down Amazon's entire shipping process, step by step. It's faster, smarter, and more complex than you think. Order placement. The journey of an Amazon package begins the moment a customer clicks Buy Now. That single action launches one of the most sophisticated logistics systems on Earth. Instantly, Amazon's backend logs the item, shipping address, payment method, and preferences, then triggers a chain of automated decisions driven by data and predictive algorithms. At the center is Amazon's inventory lookup engine, which scans fulfillment centers to find where the product is and which location can ship it fastest and most efficiently. This isn't just about finding stock. It's about forecasting demand. Amazon's AI-driven models, shaped by years of customer behavior, help shift inventory in real time, especially during spikes like Prime Day or holidays. Tools like Amify, Jungle Scout, and SellerMate feed this system SKU-level insights, optimizing stock locations and replenishment cycles. Next, Amazon checks Prime eligibility. If the item qualifies, it's prioritized and routed through the closest fulfillment center. For third-party sellers, the system confirms whether it's fulfilled by Amazon or the seller directly. Once approved, the order enters the picking queue, and the digital planning gives way to the physical execution. That's where the seller inventory shipment process begins. Seller inventory shipment. Before a product reaches an Amazon box, it first has to enter Amazon's system through the FBA onboarding process. Third-party sellers use Seller Central to list products, create shipments, and print Amazon barcodes, linking each unit to its digital record. Amazon doesn't send shipments to a single facility. Instead, it uses smart distribution logic to assign products to fulfillment centers based on demand, shipping cost, and shelf availability. Some shipments are even split to serve multiple regions more efficiently. Once packed, inventory is handed off to Amazon-partnered carriers who transport goods to the assigned centers. At arrival, unloading teams scan each box to verify contents and update the seller's live inventory. Products are then stored using chaotic storage, placed wherever space is available, not by type. This system, managed by barcodes and scanners, ensures every item can be found and retrieved quickly. As soon as items are shelved, they're live and ready for orders, sometimes within hours. With millions of sellers worldwide, this fast, flexible onboarding system is what powers Amazon's high-speed fulfillment. Once stocked, the inventory is continuously monitored and optimized, leading us straight into inventory management and storage. Inventory management and storage. Once inside a fulfillment center, Amazon shifts focus from movement to monitoring. Every product, whether a book or a flat-screen TV, is tagged, scanned, and tracked in a real-time inventory grid using sensors, scanners, and automated systems. Amazon uses chaotic storage, placing items wherever space is available. It may seem disorganized, but it allows robots and staff to retrieve products using the fastest path possible. Each shelf is barcoded, and every item's location is digitally logged with pinpoint accuracy. What makes this system powerful is automated rebalancing. If a product stored in Dallas suddenly becomes popular in Seattle, Amazon's AI can shift inventory overnight, by truck or Amazon Air, closer to where it's needed. These movements are based on AI-powered demand forecasts using sales history and even social trends. To streamline fulfillment, orders are grouped into batch or waveless picking clusters, so one worker or robot can collect multiple items in a single, efficient route. And often, Amazon's system moves inventory before an order is even placed. With help from tools like Jungle Scout and SellerMate, the system ensures products are already positioned near the customer, ready for fast, flawless delivery. Next up, retrieving the product in the picking phase. Picking the order. When an item is ordered and its location confirmed, the task moves to one of Amazon's most iconic processes, picking. This is where the warehouse floor comes alive. Either a human worker with a handheld scanner or a robotic retrieval system is dispatched to grab the product off the shelf. The instruction is precise: which item, from which bin, in which aisle, and by what time. But here's where it gets interesting. Amazon's robotic fleet does much of the legwork. Bots like Proteus, Kiva, and Sequoia move shelving units to human pickers, than sending people across the entire warehouse. Time magazine once called this a warehouse ballet where the shelves dance, not the workers. Still, not everything is robotic. Items that are fragile, heavy, or unusually shaped often require manual handling. Workers scan barcodes to confirm the correct SKU, and the system flags any discrepancies immediately. If a mismatch occurs, the item is set aside for quality control, not shipped in error. Every second counts in this phase. Picking speeds are monitored live, and the system can reroute orders if there's a delay. It's this real-time adaptability that lets Amazon scale picking to match peak seasons without sacrificing accuracy. Once the product is in hand, it's ready for its final transformation, from loose item to customer-ready parcel. That happens in the next phase, packing and packaging. Packing and packaging. Once picked, the item moves to the packing station, the final step before shipment. First, it's scanned again to verify accuracy, then passed through a box sizing algorithm that selects the smallest, most efficient packaging based on size and fragility. Much of this is automated. Box-on-demand machines cut cardboard to fit, helping reduce waste and shipping costs. Smaller boxes mean less filler, fewer trucks, and faster handling, part of Amazon's sustainability effort. After boxing, protective materials like air pillows or foam inserts are added. Fragile items are flagged and may be double-boxed. A shipping label is printed and applied, containing key data, tracking ID, destination, and delivery routing codes. This label is synced with the package's digital twin so it can be tracked through every step. Before leaving the station, the box is weighed and measured. If anything seems off, the system holds the package for inspection, ensuring errors don't go downstream. Now correctly sealed, labeled, and verified, the package is ready for the next phase of its journey, the sortation center, where routing and logistics take center stage. Sortation and routing. At the sortation center, packages shift from packaging to precision routing. These hubs sit between fulfillment and delivery stations, acting as the brain of regional distribution. Packages are loaded onto automated conveyors and scanned. Amazon's AI-powered routing system decides where each parcel should go, factoring in zip code, shipping speed, route density, and even real-time traffic. Packages with similar destinations are grouped into pallets or containers. Some head to Amazon air hubs for longer trips, others to regional delivery trucks. Routing also considers vehicle space and weight limits to avoid delays. What makes the system powerful is its adaptability. If weather, traffic, or volume overload a route, the system reroutes packages in real time, keeping deliveries on track. These sortation centers enable same-day and weekend shipping, pushing parcels to where they need to be without relying solely on traditional carriers. Once grouped, labeled, and scanned one final time, the packages are dispatched to the local delivery station, ready for the last-mile journey to your door. Delivery station processing. Once sorted, the package arrives at the local delivery station, typically within 50 to 80 miles of its final destination. These stations are smaller and more agile than fulfillment centers, designed specifically for last-mile delivery. Their goal is simple: turn sorted packages into optimized driver routes and get them on the road as fast as possible. First, packages are unloaded and scanned into the system. This confirms arrival and assigns them to a delivery batch based on geographic proximity. Amazon's routing software then uses dynamic clustering to group orders within a neighborhood or zip code. This grouping isn't just random, it accounts for traffic, driver familiarity, and package urgency. The packages are staged in designated racks or bins, organized by route and driver. This is when systems like Amazon Flex and DSP, Delivery Service Partner Networks, come into play. Independent drivers arrive and scan their route manifests, loading their vehicles based on precise delivery sequence recommendations. If a package is particularly time-sensitive or fragile, the system flags it for priority handling. Everything is orchestrated with precision, Even battery-powered Scout robots are deployed in select neighborhoods from this station. Once the driver or device is ready, they're dispatched with a final manifest. Bahnübernahmen INFS, the digital roadmap that guides them door to door. The station, now cleared of its batch, prepares for the next wave, keeping the flow constant and efficient. Now, the final journey begins. The package is on the move toward its destination. Last mile delivery. The last leg of the journey is often the most complex and expensive. Known in logistics as the last mile, this stage takes a package from the local delivery station to the customer's doorstep. Amazon has invested heavily to control this step internally, building a fleet of Amazon Flex drivers, DSP vans, and even autonomous robots to handle the job. Drivers begin their shift by scanning their route and vehicle load, then head out on optimized paths calculated by Amazon's routing software. These routes aren't static, they adjust based on live traffic, weather, and delivery windows. Some areas use VAPOR, Vision-Assisted Package Retrieval, which helps drivers sort and locate packages faster from their cargo bays. In select neighborhoods, Scout robots carry lightweight packages to homes, navigating sidewalks and stopping at programmed destinations. While still limited in scope, these bots represent Amazon's push toward scalable, driverless delivery. What makes this phase so efficient is data-driven rerouting. If a road closure or unexpected delay occurs, Amazon's system updates the driver's route in real time, always aiming for the shortest delivery window. As the driver nears your home, the system sends delivery notifications. In some cases, you'll see a map showing exactly how many stops away your package is. And when the package arrives, that's where Amazon's obsession with confirmation kicks in. Customer receipt and experience delivery isn't complete until the customer has the package in hand or safely waiting. Once the item is dropped off, the driver uses the Amazon Flex app to take a photo of the package at the delivery location. This acts as both confirmation and protection against loss or theft. If the item is delivered to an Amazon locker, customers receive a one-time code to retrieve their package at their convenience. Lockers are increasingly used in high-density areas or locations with high porch piracy rates. For some customers, Amazon Key allows delivery inside a secured entryway or garage using smart locks and driver verification. As soon as the package is confirmed as delivered, a notification is triggered, and the system updates the order status. If something's wrong, say the item was damaged or never arrived, the customer can instantly access Amazon's support system for a return, refund, or redelivery. This stage is where customer trust is built or broken. Amazon's obsession with tracking, verification, and hyper-responsive service is what helps it maintain dominance. It's not just about the speed of delivery, it's about making that delivery feel effortless and dependable. But what happens when something does go wrong, or a customer simply changes their mind? That's where Amazon's reverse logistics engine comes into play. Returns and reverse logistics. Amazon has turned returns into a frictionless experience. Something that once terrified retailers is now a pillar of customer satisfaction. If a customer decides to return an item, they initiate the process through their Amazon account. In most cases, they're offered multiple return options: drop off at UPS or Kohl's, pick up by a carrier, or box-free returns at Amazon lockers or partner stores. Once a return is initiated, a return authorization label is generated, linking the item back to its order and tracking number. Return products then flow to dedicated return centers or designated fulfillment warehouses, depending on their category and condition. Upon arrival, returned items go through a multi-step inspection. Some are simply unopened and restockable. Those head back into inventory. Others might be lightly used and eligible for Amazon Renewed, refurbished goods. If damaged or defective, products are either recycled, liquidated, or destroyed. All of this happens within Amazon's internal systems, which ensure that inventory, financials, and customer records remain synced. Refunds are processed quickly, sometimes within hours of drop-off, and customers are updated at every step. What makes Amazon's reverse logistics powerful is its tight integration with the rest of the supply chain. Returns don't disrupt the flow. They're absorbed by it. Each return teaches the system more about buyer behavior, product flaws, and vendor performance, feeding directly into product ranking, restocking, and forecasting algorithms. With this, Amazon closes the loop, delivering not just packages, but a full-circle experience. Warehouse automation and robotics. At the core of Amazon's supply chain lies a powerful alliance between humans and machines. Today, over 750,000 robots work alongside employees across Amazon's fulfillment network, an astonishing number that continues to grow. These robots are more than tools. They're part of a vast, intelligent infrastructure designed to eliminate inefficiencies and increase safety. There's Proteus, the first fully autonomous robot capable of freely navigating warehouse floors without needing tracks. Then there's Robin, a robotic arm that identifies and sorts packages by shape and barcode. Sparrow handles delicate picking tasks, something once thought impossible for a machine. And Sequoia, Amazon's latest innovation, coordinates inbound inventory, unloading and sorting faster than any human team ever could. These robots operate on advanced computer vision and machine learning, constantly improving with every action. They scan SKUs, avoid obstacles, and work seamlessly with human associates in tightly choreographed routines. As one Amazon VP said, "We don't automate jobs, we automate tasks." That's an important distinction. The introduction of robotics hasn't removed the human role. It's shifted it toward maintenance, oversight, and optimization. With robots handling repetitive or high-risk functions, employees focus on exceptions, quality control, and system management. It's a safer, faster, and more scalable way to run the modern warehouse. This ecosystem of robots, sensors, and smart logistics forms the physical backbone of Amazon's speed. But what ties it all together is something even more invisible: the AI that controls it all. Back-end optimization and AI. Behind every package, every robot, and every decision, there's data. Mountains of it. Amazon's supply chain doesn't just rely on physical movement. It thrives on real-time optimization powered by artificial intelligence and predictive analytics. At any given moment, Amazon's system tracks the performance of every fulfillment center, forecasts staffing needs, anticipates order volume spikes, and identifies potential delivery delays. Using this data, it adjusts operations proactively. This means rerouting inventory before a bottleneck happens, or launching surge hiring in areas expecting a delivery boom. Amazon even builds digital twins of its warehouses, fully virtual models where robots can train, routes can be tested, and layout changes can be simulated without real-world risk. Every second of downtime, every late shipment, every returned item becomes a data point that improves the system. The AI doesn't just learn, it acts. If one warehouse is underperforming, load is shifted. If too many orders are late in a zip code, routes are reconfigured. And if the global supply chain shakes, as it did during the pandemic, Amazon flexes its system accordingly. This relentless efficiency has an endgame. Amazon is aiming to cut over $10 billion on logistics costs by the end of the decade without sacrificing delivery speed. That level of cost control isn't just smart business. It's how Amazon maintains prices, scales globally, and keeps Prime fast. With the physical world humming in sync with the digital brain, Amazon's system is primed for one thing: scalability. Scalability and global reach. What makes Amazon's shipping process truly extraordinary isn't just how it works, it's how far it reaches. With over 1,000 facilities globally, including fulfillment centers, sortation hubs, delivery stations, and air hubs, Amazon's logistics network is one of the largest and most advanced in the world. Through programs like Fulfillment by Amazon, FBA, sellers anywhere, from small-town artisans to multinational brands, can plug into this system. Amazon stores their inventory, picks, packs, and ships it, providing two-day or even same-day delivery to customers around the world. For global sellers, Supply Chain by Amazon adds another layer, handling international freight, customs clearance, cross-border compliance, and regional storage. Whether a product is made in Shenzhen, Mumbai, or Ohio, Amazon can deliver it to a customer in Los Angeles, Berlin, or Tokyo with remarkable speed. Flexibility is key. Amazon supports FBA, FBM, fulfilled by merchant, and MCF, multi-channel fulfillment, allowing sellers to choose how and where their products move. Behind it all is the same AI engine, ensuring the entire pipeline remains lean, fast, and responsive. But scalability isn't just about tech, it's about consistency. Whether a package is delivered in Chicago or Seoul, customers expect the same speed, the same tracking, and the same reliability. That's the power of this global infrastructure. It allows localized service with global reach. From a single click to global delivery in under 48 hours, Amazon's shipping system is a testament to technology, data, and disciplined logistics at scale. It's not just fast, it's a blueprint for the future of supply chains. From predictive algorithms to doorstep delivery, Amazon's shipping process is a masterclass in modern logistics. Every step is engineered for speed, scale, and reliability. If you've ever received a package in under 24 hours, now you know how. Thanks for watching. Don't forget to like, subscribe, and share for more deep dive breakdowns.